Welcome you students. In this video lecture, I come up with 4 twisted questions from the conic curves. And here in this video, I will give you a hint to identify the curve and how to proceed with the thing to get the profile. Right? So take the first question. The vertex of hyperbola is 66 mm from the focus. Draw the curve. If the eccentricity is 3 by 2, draw also tangent and normal at any point on the curve. So if you take the given data, see, before taking the given data, I shall make you remember the basic terminology involved in the construction part. So the vertical line D dash, which is a directrix, and see, this is the axis, we know it A, and in the axis we have the focus, and in between, if I take this as C, in between C and F we used to have the vertex. See, now try to read the question. The vertex of hyperbola is 66 mm from the focus. Vertex of hyperbola 66 mm from the focus. Here is the vertex from the focus. That means they are talking about the distance VF as 66. So in the question, VF is given as 66, and the question itself, they have said it's a hyperbola. No worry in identifying the curve. But the thing is, always we used to get the value CF, am I right? We used to get the value, the distance between focus and the directrix we used to get in the normal problems, but in this we got the VF. So how we are proceeding? Fine. So next, what about the eccentricity? Yes, it is 3 by 2. So now our task is, we need to identify CV distance, VC. We need to identify VC. So that can be taken from the eccentricity. We know the eccentricity is VF divided by VC. If you equate it, we get VF divided by VC equal to 3 by 2. Am I right? So from this we can take the value of VC. So here VF is given as 66. If you do the mathematical calculation, we get like this. From this we can find VC value. That means do cross multiplication. So what happens? This will go like this. So if so, we get 44 mm as VC. So it is so easy. If you are constructing it, first draw D dash and D and just take the VC first. Always in general conditions we used to take CF distance, but here we are going to take VC first. Okay, VC is 44. From C measure VC as 44. 44 and place it. And from V in the question 66. So from V take focus and plot the F. Then the usual procedure, we used to extend the line from the what? Vertex perpendicular to it, and we used to measure VF and just we will have the arc. At that time we get the guideline. Then it is so easy. We have to make odd interval, that means equal interval in the bifurcating line in the axis. Okay, afterwards by measuring the individual lines and fixing the focus center by having the arc in the respective line in the top and bottom region, we get the points. Okay, so if you do so, we get the curve of hyperbola as this manner. Okay, so let me move to the next question. Second one, the question is, a fixed point is 60 mm from a fixed straight line. Draw the locus of a point P moving in such a way that the ratio of the distance from the fixed straight line to the fixed point is 4 by 3. Draw the tangent and normal. See, first take the given data. Fixed point is 60 mm from the fixed straight line. Fixed point in the sense, yes, it's a focus. What about the fixed straight line? It is nothing but directrix. Directrix, right? So here VF distance is given 60 mm. VF distance is given 60 mm. What about the eccentricity? What about the eccentricity? Whether we have eccentricity, just read out the ratio, what it is given. The distance of moving point from the fixed straight line to the fixed point, right? That means they have given distance of moving point from the fixed straight line in the sense directrix. So VC to the distance of moving point from the fixed point VF they have given. What about our ratio eccentricity? It's VF divided by VC, right? VF divided by VC. So here the given the ratio is just a reciprocal one, right? Reciprocal one. So by taking the reciprocal of VC divided by VF, we get the eccentricity value. Okay, so that means just take the reciprocal of this. That means 1 divided by VC divided by VF. We get 3 by 4. This is the E. 3 by 4. Okay. So what's the curve? Yes, it is less than 1. E is making less than 1. Since it is 3 by 4, we get 0 point something. So it is a less than 1. So that we can say it is an ellipse. Okay. Now we came to know the given curve is an ellipse. So it is easy. The simple procedure which I have taught you in the last videos explaining about the construction part in the ellipse. Just you follow it, you can make the profile of ellipse. Then we shall move to the third question. A fixed point is 50 mm from the fixed straight line. Draw the locus of point P moving such a way that the distance from the first condition is fixed point is twice the distance from the fixed straight line. Second one, fixed point is half the distance from the fixed straight line. Third one, fixed point is equal to the distance from the fixed straight line. So we shall start with the first one. First, try to take the given data. Fixed point is 50 mm from the fixed straight line. We know fixed point in the sense it's a focus, and fixed straight line in the sense it's a directrix. So they are talking about what? VF as 50. VF distance is mentioned. And see here, any ratio in the question is visible to you? Any ratio? No, right? There is no ratio about eccentricity. But indirectly in the conditions they are talking about the ratio, right? So read it carefully. Draw the locus of a point P moving such a way that the distance from the fixed point, okay, so for which we can draw the terminology diagram first, d dash d, and here the focus, and in between the C and F we have the vertex, so this is the axis, right? Fine. So point P, moving point, is moving in such a way that the distance from the fixed point is twice than the distance from the fixed straight line. That means fixed point in the sense focus, then moving point in the sense nothing but a vertex, and we know directrix other name is a fixed straight line. So here it is being said the fixed point is twice with reference to moving point. The fixed point is twice when compared with the fixed straight line. So I can say if I take CV as x, this BC will be 2x, since the distance of moving point to the fixed point is twice than the distance from the fixed straight line. So I have taken this as x so that it will be twice the distance of this. So we can take like this. So from this we can take the ratio E. We know the formula VF divided by VC, right? What about the VF? 2x. And what about the VC? X. So that this x and x get cancelled and it will be 2 by 1. What about this E? Whether it is less than 1 or greater than 1? It's a greater one, right? E is greater than 1, so that the given curve is a hyperbola, right? We shall move to the next one, the second case, right? Here see point P moving in such a way that the distance from the fixed point is half the distance from the fixed straight line. That means this is a C, and here we have the F. In between we have the vertex. Okay, commonly VF is mentioned as 50 mm. Here it is mentioned as the distance from the moving point to this fixed point, that means to the focus, is half the distance from the fixed straight line. So that if I take this CV as h, I can say this is h divided by 2. This fixed point is half the distance of the fixed straight line, right? So I have taken this as h and this as h by 2. If you take like that, you can get the ratio eccentricity E by F as EF divided by VC, so that we get VF is x by 2, and what about VC? It's a x. So that this x and x get cancelled and we get 1 by 2. Okay, now check what about the eccentricity. If it is greater or less than, it's a lesser value, right? It's a lesser value, lesser than 1, so that we can say it's an ellipse. Okay, move to the third condition. The moving point moving such a way that the distance from the fixed point is equal to the distance from the fixed straight line. So that means D dash D, here we will have the focus and this would be C and between V. What it is saying, the distance from the moving point to the fixed point is equal to the distance of moving point to the fixed straight line. Both are equal, so that I can take this is X as well this is H. If so, the eccentricity Vf divided by Vc becomes H divided by H. The H and H get cancelled, so that we get 1 by 1, right? So I can say the eccentricity is equal to 1, so that it's a curve called parabola. Here the Vf is same, which is 50 mm. Okay, fine. Next, fourth question. A fixed point is 75 mm from the fixed straight line. Draw the locus of the point P moving such a way that the distance from the first condition fixed straight line is twice the distance from the fixed point. Second, fixed straight line is half the distance from the fixed point. Third, fixed straight line is equal to the distance from the fixed point. So first go with the first condition. Here in the first line, fixed point is 75 mm from the fixed straight line, that is nothing but Vf, which is given as 75 mm. And see, this is the normal terminology we used to do in the conic curves. So here we have focus, and between C and F vertex will be there. Okay, this is the axis. Read out the first condition. A point P moving such a way that the distance from the fixed straight line, that means this moving point, this distance is twice the distance from the fixed point. That means when comparing with the distance of fixed straight line is twice than this Vf. So if I take this as X, Vf as X, this will be 2x, twice than this Vf, right? So that means the eccentricity Vf divided by Vc, we get Vf is X and Vc is 2x. So X and X get cancelled, so we get 1 by 2. E is 1 by 2. It's a less than 1. E is less than 1. So we can say the given curve is an ellipse. Right? What about this second condition? The same Vf value 75, and if I take the lines, it will be like this. Read now. The point P moving in such a way that the distance from the fixed straight line, moving point with the fixed straight line is half the distance from the fixed point. So for this distance, this distance is half. So if I take Vf as X, this would be X divided by 2. So if we take the eccentricity, what happens? Vf divided by Vc. So Vf value is X. What about Vc? Is X by 2. X and X get cancelled. You will get what? 2. Am I right? 2. What type of curve is this? Since it is greater than 1, the eccentricity is greater than 1, it's nothing but hyperbola. It's a hyperbola. What about the third condition? Third condition, it is easy. The moving point is moving in such a way that the distance from the fixed straight line is equal to the distance from the fixed point, right? So here as well VF is 75 mm, and if you take the construction basic terminology line, this would be the case. Here it is said the distance from the moving point to the fixed point and the distance between the moving point and the fixed straight line is equal. So if I take this as x, this is also x, right? So the eccentricity will become Vf divided by Vc. If you substitute the values, x divided by x, so that we get 1 by 1, it's a 1, right? Eccentricity is equal to 1. So what is the curve? It's a parabola. Okay. So I hope you understood the four varieties of problems. Thank you so much.